Good day to you. In today's lecture, we will learn right methodologies and systematic approach for repairs, rehabilitation and strengthening of RCC structures. We will learn this with the help of various case studies of different types of structures. The course content comprises of basics of repairs and strengthening, approach to systematic repair and strengthening methodology, case studies for various type of structures and strengthening techniques. So, basics of repairs and strengthening. In your previous lectures, you had learned in detail about basics of repairs and strengthening. I will just go through the brief for same. What are the typical issues in RCC structures? One of the main issue in RCC structure is corrosion of rebar. Any RCC structure cannot be constructed without reinforcement. And reinforcement are prone to corrosion. Because of corrosion, it induces cracks in RCC elements. If these cracks are not attended in time, it leads to advanced stage of corrosion defects, what we commonly termed as spalling. Another major issue is leakage or seepages. They are adding to the corrosion of rebar. Also, they are making the structure not rehabilitable. If there is an ample amount of leakage, you cannot use the property beneath the slab or backside of the wall, or if there is a server room or there is a control room in the industry, the leakage will create a problem. Or if in a chemical plant, if there is a leakage, it will create lot of issues. So this is one of the next major issue. Another is deflection of structural members, or you can say failure of elements in form of shear, flexural, compression, deflections, which may lead to various problems like crushing of concrete, hogging, sagging of the slab, and all sorts. You had learned this in detail in your earlier lectures. What are the factors that lead to this problem? Broadly, they had been classified in 4 different types. Factors which are built-in problems. Built-in problem means design fault, workmanship fault during construction, wrong selection of type of material, wrong specification of material or waterproofing system failure, wrong specification of waterproofing. If there is a problem with the waterproofing, it will lead to leakages, further might lead to cracks, and being a cyclic circle, it will lead to corrosion, again leakage, again more cracks. if the right material is not selected. What do you mean by right material? If you are not selecting a sulfate resistant cement for an underground structure in a coastal area, then your below ground elements are not resisting to the sulfate attacks. You will have problem. If you are not selecting a material considering durability and performance of the element, you may use slag cement in an adverse environmental condition. It's going to be helpful. Wrong selection for material of protective coating. Wrong specification. These all factors are built-in problem. External causes. Environmental effect. It can affect your structure. If it is in coastal environment, we had come across that within a span of 3 to 5 years of construction, because of environmental effect, there are major issues. Another external causes may be carbonation in densely trafficable area, chloride attack, sulfate attack, chemical plant environment. So this external causes various problems which we had discussed above. Man-made causes. Yes, we also do various problems to our structures. We do faulty design, we change the use of the structure, people are making addition and alteration in the structure without considering overall capacity of the structure or what could be the problem. If in a commercial complex to have a large hall, people cut the column if it is coming in between their interior planning. There are examples wherein the building has collapsed because of that. Change in use. If building has been designed for residential purpose and because of one or other reason, if the change in use to a commercial or a hospital, then your loading changes and your building strength requirement changes and you need strengthening. There can be natural calamities, earthquake, cyclone, floods. This all create a huge damage, huge impact on our structures. We need to carry out repairs and rehabilitation and strengthening for various structures because of any of these four problems. How to do a systematic approach for repairs and strengthening of such structures which need treatment. Very first thing comes is visual inspection. It has to be on the basis of visual inspection. You need to observe the structure properly. carefully see the pattern of the cracks, alignments, signs of leakages, color of the building concrete, corrosion marks, how particularly such defects are on one face, another face, bottom of the building, settlement of the building. Everything has to be noted and mapped on the drawing, and interpretation has to be carried out to know the reason of the failure or to know the reason why you need repair or strengthening. After you carry out visual inspection, the second most important point is to carry out NDT and partial NDT results. I am sure you are well aware of various types of non-destructive and partially destructive test. But it is very important to select the location of test and what type of test should be carried out. If based on your visual inspection, it is required to carry out corrosion survey because you found that visually, apparently, it is a problem because of corrosion of rebar, then you need to carry out chemical analysis of the concrete, half cell potential, corrosion resistivity of the concrete, like corrosion resistivity of the concrete, so that how fast there is a movement of ions. If it is more resistance, then the corrosion rate will be slow. You can also measure the corrosion rate. But if you found that there is no corrosion and there is only a deflection or a crack, then you don't need corrosion survey. So selection of type of test is very important. Also, location of test. You should get the test at good condition, bad condition, and in between. Try to get 3 type of location so that you can compare the test results for that building, apart from comparing it to the latest codes. Once you had done the visual inspection and carried out test, one should know why you need repairs and rehabilitation or strengthening of the structure. What is the requirement? You can ask to the owner or a user, and expected life of repair. A life is very important to determine how much my repair or strengthening will last. You cannot afford to spend handsome amount of money on repair today, which will last for 25 years, or you can spend 25% or 40% of same amount and you may go for repair next time after 10 years or 15 years. Or sometimes it is so important that you need to select the repair methodology such a way that your repair and strengthening scheme should last the age of the structure. So that is one more important point. Then selection and evaluation of repair material. What material should be used for proposed repair and strengthening? You should evaluate the material. Material means starting from rust removal material, corrosion protection for rebar, bonding agents, strengthening material, polymer modified mortar material, microconcrete, or it may be steel plate, steel, cathodic protection material, protective coating, waterproofing. You cannot use a epoxy grout for injection grouting for a leaking cracks. Vis-a-vis, you cannot use a polyurethane grout for structural crack repairing. Similarly, you should not use polymer modified mortar for a large area and very high thickness. It is always good to go for microconcrete. So once you have selected the material, it comes the budget also. Based on your approach from visual inspection to selection of material and the system, if the owner, user or client doesn't have money for a life of 25 years, then you may need to rethink and to carry out entire exercise depending upon the budget. Also, limitation and constraint to work. You need to design or approach to a system such a way that the work can be carried out in spite of constraints or limitation. You cannot have a bridge or a traffic stop for a very long period in a city where you don't have an easily available alternate route. Or you cannot carry out some repair of a building, maybe a university, during the exam time. So in vacation you had a limited time of 2 months or 1.5 months. So time is the constraint. Similarly, in industry, plant working condition, shutdown is the constraint. Accessibility to the location is the constraint. Working condition is the constraint. So all constraint has to be taken care. So based on type of causes, type of problem, systematic approach evaluation, a right repair methodology has to be derived. We will see practically how this systematic approach has been implemented at site. Also, what is the repair scheme requirement? It should be a holistic job specification. You need to frame your specification in such a way that it complies with all the system of repairs and strengthening. You can have a carbon fiber strengthening, but then you need a final finish with a protective coating, or you may need further beam strengthening by using steel plate. You need to check whether these both will comply or not. You must identify the cause. Don't see there is a crack and you can repair it with injection grouting or making it V-groove and filling it with some epoxy putty or mortar. Find out why that crack has occurred and prepare a scheme which will eliminate the cause of that crack. So this is second important point. Third is compatible material. The material which you are going to use for repair should be compatible with the parent material. If it is not compatible, it will be a big failure of specification stage. Corrosion control mechanism wherever possible. Like if you had identified the cause and if it is corrosion, if you do proper preparation, do proper repair, but if you do not incorporate corrosion control measure, you will have similar problem in near future. So try to incorporate corrosion control. That is the best way of elimination of problem of corrosion. You can use sacrificial anodes, you can use cathodic protection by means of ICCP and various other means. Finally, protective coating. Type of coating, thickness of coating, application methodology, that all has to be derived based on the site condition. You cannot have a non-aliphatic epoxy coating on outside of the surface, or you cannot have a simple anti-carbonation coating for a chemical resistance element. So, a protective coating has to be selected properly. Finally, post-NDT. A systematic approach of repairs complete with a post-NDT. It is like carrying out an X-ray after your fracture got healed, which ensure that yes, my structure is good now. If you carry out NDT post repair. So, with this base, we will go one by one. These 5 case studies, 2 for bridge, 1 for residential building, 1 for commercial building, and 1 for industrial plant. Let's start with first case study. It's a bridge structure. You can see this bridge, it's few kilometers long. It's located in Louisiana, United States of America, in New Orleans. This bridge is 103 years old. The problem occurred when there was a hurricane named Katrina a few years back. Because of aging, because of corrosion and hurricane, when they checked the bridge, they found there were a lot of cracks, spalling in the beam of bridge, there were corrosion in the piles, and they were not sure that it can withstand another hurricane. Although it has withstand the Katrina hurricane, but it was always a question. So a detailed study has been carried out in terms of visual inspection, various tests has been carried out, and it was confirmed that there is an ongoing corrosion. So electrochemical repair and strengthening was the requirement. Being an important bridge over a very wide river, so budget was not the constraint. But there were limitations like adverse working condition. It's a 100-year-old design. It's not complying to the latest code. You can always replace a partial deck of the bridge, span by span. This is a common practice in USA and Canada, that is North America. But to replace the pile, it's not that easy. So they want to carry out pile protection, like protecting the pile against corrosion and strengthening for further 50 years or more than that. This was the condition of the beam. You can see cracks and spalling. The holding bars. These are the bars which are holding the main reinforcement. You cannot see the holding bars, they had fully corroded here. There were corrosion in the pile rebar. So a solution has been derived. All the beams need to be properly prepared by removing all the loose concrete or the concrete which is not in good condition. The good quality concrete, although may be contaminated, is not removed. All the steel reinforcement were grit blasted using copper slag. You see the quality of surface preparation. This is an old steel reinforcement, just grit blasted. It looks like SA half type cleaning of the rebar. New rebar has been planted and a sacrificial anodes, this white anode, are being tied to the rebar based on the design of steel density of the bridge, considering the life of 25 years for anodes. So the concrete damaged surface was prepared, steel was cleaned and protected, and an electrochemically protection using sacrificial anodes has been installed. Such a long bridge, so much spans, a very deep river. It's difficult to do shuttering. So a GI shutter has been decided to carry out reinstatement of damaged portion of the beam using microconcrete. These GI shutters were held in place with horizontal supports, what you can see in the photograph. Whole U-shaped shutter were anchor bolt and they had been supported horizontally. That way you don't need a bottom support in the water. There were ports at the bottom to pump the microconcrete. And this microconcrete has been pumped by keeping the pump on the shore or on the boat. So once it is filled, shutters are removed. It's good that the all span were of same size. So these shutters, galvanized iron shutters, can be used for multiple spans. One interesting thing is no stirrups or shear reinforcement were found in the beams. Amazing, the beam are without shear reinforcement stirrups, standing for 103 years, withstanding hurricane, but latest code doesn't permit this. So structural analysis has been carried out and shear reinforcement were provided using carbon fiber wrapping in U shape as per equivalent amount of steel reinforcement required for shear. That amount of carbon has been installed in the form of wrap on 3 sides. Structural analysis has been carried out based on prevailing codes, and design calculation for CFRP has been carried out based on ACI 440-2R 2017. So you had repaired and strengthened your beam to match the need of enhanced life, longevity, easiness to construct, the right material specification. Now question comes for the piles. So a new system has been installed for the protection of piles from corrosion and strengthening. All the piles, there are more than 6,000 piles, has been protected in the tidal zone, which is most prone to corrosion because this river meets sea very nearby. A zinc plate wrapped in a cloth, specially designed by a competent company, were installed on all the sides of pile, and a connection was established. You can see the column broken for establishing the connection between the zinc and the rebar, and the length of anodes were such that because of the cloth, by capillary, by weak action, this brackish water will keep zinc activating, will keep zinc corrode, so that the steel are protected from corrosion. After temporarily tying the anodes to the pile, a special PVC modular formwork which comes in strips, and it can take any size, any shape, has been erected, and the annular space between the pier and the stay in place formwork is filled with microconcrete along with additional reinforcement provided as per the structural design. So, you have a strengthening requirement, you have a corrosion protection requirement, a long-term requirement, easy to work in adverse condition. Everything has been sufficed by providing a PVC modular jackets with microconcrete with sacrificial zinc anodes activated by wick action for all the piles. This way, it was ensured that the piles and the beams of the bridge will last for more than 50 years. We will go to second case study. The problem was man-made. Very interesting case study. This case study is for a missing pile of a bridge, of a missing pier of a bridge. This bridge is connecting an intake of a power plant which is well inside the sea to the way ahead power plant which supplies water. Now, one of the pile, you can see the pile number 20 was broken or damaged by a hit by a ship. So, this span is not safe. This is pile P19, this is P21 and pier 20 is missing. Constraint. If there is no deck slab, you can have an adjoining pile, you can design it. But there was a pile, broken portion inside. You cannot grow the pile. You cannot have an adjoining location pile. Practically, how to construct that? That was a limitation. Here, a non-destructive test or visual inspection is not that important. The important is design for strengthening, how to provide support for missing P20 with durability and performance. Conditions are very adverse, you are in mid of sea, and how to transfer the load to the newly planned truss. I will explain in detail. With the help of IIT Madras, a scheme has been derived wherein a new truss has to be fabricated, a new bracket has to be constructed, truss to be placed on these two brackets, another stub piece of microconcrete to be installed with base plate, and then this whole truss has to be loaded, jacked such a way that the load being transferred to these two piles. Also, analysis has been done that these two piles are capable of taking the 50% load from the missing pile. So, these two brackets has to be constructed on P19 and P21 for support this P20. So proper access has been made, a hole has been drilled in the liners, 32 mm hole, depth as per requirement of calculation. Rebar grouting of the main rebar has been done. A sacrificial anode, again electrochemical repair for protection of this reinforcement from corrosion because of environmental effect. Location of the structure, it will induce lot of corrosion. So the steel has been installed using rebar grouting, sacrificial anode has been installed, a zinc rich coating has been done on the rebar, shuttering has been provided, and a micro concrete has been poured in the shuttering to form a bracket. These bracket again been coated with an high performance anti-carbonation, anti-chloride ion diffusion, acrylic aliphatic coating. This is how two new brackets has been made. On these two new brackets, a truss will be placed. Now, this truss has been fabricated on shore. The available pipe thickness was 350 mm and the available pipe thickness maximum was 17.5 mm for a dia of 350 mm of pipes. Although that was not sufficient, but initially a tubular truss has been fabricated, what you can see in the photograph. This truss has to be taken and placed on these two brackets. That was a big problem. But thanks to the contracting team, they had carried this truss by launching and using winch from the existing support of the bridge by means of a wire rope, and whole this truss has been launched from shore right away up to bracket and placed on two brackets. After placing, as I told you, that the specification of available pipe were not sufficient, so entire truss has been strengthened further by using carbon fiber strengthening. A proper care has been taken that there is no direct contact between the carbon fiber and the MS pipe, which might induce further dissimilar metal corrosion. So there is an adhesive or a surface is prepared in such a way that there won't be any direct contact between the carbon wrap and metal. There will be an insulating coating in the form of epoxy, which will not allow electrons or ionic parts to travel from carbon to iron. No direct contact. After carrying out carbon fiber strengthening, a further protective coating has been applied on carbon fiber system. So, your brackets are in position, truss has been put in position, protected properly, then jacked to take the load of the pile. So it is properly transferring load exactly on P20, not on P19 and 21 as if it was doing when there was no pile. And proper deflection, loading check has been carried out at location. And most important, while launching this girder, there was a cyclone. It's our luck that contracting team doesn't have any major loss in form of loss to truss or any other thing. So, a design issue, material availability issue, adverse working condition, and new concept. This is how a missing pile has been replaced and been strengthened. We will have another example of commercial building. Man-made cause again. Additional load. This is an ongoing building which is meant for commercial use. When they had constructed up to 7th floor and 8th floor was under construction, the 8th floor was sold to a company who is in business of IT sector. They are supposed to have a large server placed on 8th floor slab, and this additional load, this live load was not considered in the original design. So, considering the new load, whole structural analysis has been carried out, and it was found that 4th, 5th and 6th floor columns, few of the columns of these 3 floors were not adequate, and they found to be deficient for moments. Axially, for compression and for shear, they were safe. As I told, the 8th floor was not constructed. So, based on new requirement, the slab and beam of that floor design has been altered, and there was no requirement of strengthening for that floor. So, only requirement was for few of the column on 3 floors. But the constraint, the lower 3 floors were already constructed. The floor above it were also constructed, and architect and interior design and use of the lower floors doesn't permit to have a jacketing or increase in size of the column. Also, if you want to increase the size of only 3 intermediate floor, you need to carry out jacketing right up to the basement, which again a limitation space wise, hindrance wise, cost wise. So, we had designed an CFRP system as an alternate. Without increasing the size of the columns. So, CFRP laminates plates of 100 mm wide and 1.4 mm thick were installed on the face of the column. The cross-section area of the laminate, that is 100 into 1.4 into numbers of laminate, were derived on the base of area of steel required for the deficient moment. Once the numbers has been derived, a proper care has been taken for junction development, that is to transfer the load from column capital to the column. The column which were supposed to be strengthened, a proper surface preparation has been done to even out the face of the column. Also, the edges were rounded because there is a partial confinement also for enhanced moment to take care of shear and compression, and to avoid delamination of the laminates. So rounding is very important. The radius of rounding should be based on the design. If in your design you had taken RS25, there should be minimum rounding of radius with 25 millimeter. If it is taken 50, you should have a rounding of 50 millimeter. Surface should be even out. All the protruding things should be grounded. Now, to avoid delamination, fiber anchors made from carbon fiber were installed at the top and the bottom of the column. You can see a hole which has been drilled for 10 mm dia and 100 mm depth. A stem of the anchor being inserted inside and grouted using epoxy, and fan portion were inserted in the slots. This is one anchor. There are 1, 2, 3, 4, 5 and 6 anchors. 1, 2, 3, 4, 5 and 6 anchors. So, there will be 6 plates like this. Once the anchors are installed and cured, plates are installed on the surface prepared, and the glue between the adhesive between the plate and the anchor will avoid delamination, debonding. So, you have surface prepared, you have anchor installed and laminate installed. Then you need junction development. So, you need to prepare surface on the capital up to the size of junction development and on the wall, and also preparation for the bands. I will explain further why and how the bands and junction development has been carried out. Whatever amount of carbon provided on a one face of the column by means of laminate, say 140 into 6, that much amount of carbon has to be provided for junction development in the form of L shape. So, 500 mm by thickness of 430 GSM CFRP will suffice one laminate. So, this is 3 layers, this is 3 layers, So you have a proper amount of carbon transferring load from slab to the laminates. Anchor has to be installed here, anchor has to be installed here, here and here to avoid debonding. Further, this type of CFRP wrap bands all around the columns has to be installed. This will help in enhancing the shear capacity because of the enhanced moment carrying capacity due to laminates also, and also it will not allow this laminates to bulge out, to debond. Also it will help in some increase of compressive strength by way of confinement. This is the completed, all these bands will be carrying an anchor at the lap. This is how a completed CFRP columns looks like. It is having a laminates, bands, anchors before the laminate, anchors on the band, a L junction developed equivalent to laminate carbon area and anchored properly. Finally, this will be covered with a plaster to have a fire rating of 2 hours as per requirement of client. So, your strengthening is safe. This whole CFRP strengthening was possible because this element column was complying to the requirement of ACI 4402R. That column should be capable of DL plus 0.75 LL without wrapping. So, you cannot simply go for CFRP for all the members. We will have one more case study for punching shear failure. It's a residential apartment wherein because of design failure, there was a typical punching shear failure cone. It failed in punching shear law. It has a ground floor and the first floor were continuous. There were 3 towers like ground floor, first floor and 3 towers, 2 floor and 4th floor. When they were constructing the 4th floor, there was a blast and these cracks were developed. A proper analysis has been carried out, redesigned, and it was been found that there was a steel deficiency and it was a detailing blunder. Constraint was you cannot demolish entire floors. You have to do it with confidentiality. Cost has to be considered because this is a real estate project, time limit, and how to design and how to install it, the deficiency in terms of steel. So it was decided to incorporate a column capital where there were not. So the surface was roughened within 6 mm amplitude and designed shear anchors were installed. The 6 mm amplitude and the numbers of shear are such that they will transfer the shear load to the main slab. It is based on design. It's not that 3 numbers per square meter. Vs, Vc, friction coefficient, everything has been considered, and then what shear force it's going to transfer has been designed. The portion which was distressed crust has been removed after proper supports. The outer part was also roughened. New reinforcement has been tied. Proper shuttering has been done, closed from the bottom, and the micro concrete was pumped from the top. And this is how the column capital looks after completion. So additional capital was been incorporated. Now the second requirement to suffice the positive and the negative moment reinforcement deficiency. So these type of 25 millimeter by 2.4 millimeter thick carbon laminates were used by nearly surface mounted system as per ACI 440. Like at the location you need to cut the slots and insert this in the slot with the use of adhesive. This is the completed one photo. These holes are for pouring the micro concrete beneath the slab, but this is good for negative reinforcement part on the top of the slab. The area where the concrete was broken, there also at the top a steel has been inserted. How you had inserted the steel? From the bottom in positive moment deficient area, a groove of 1.5 times the rebar dia, a 12 mm rebar has been inserted into the slab from bottom. The whole slot has been made and the steel has been inserted by using a special adhesive. The distance between each slot, the size of the slot has been designed as per ACI 440 NSM bar insertion parameters. Also, this entire area has been coated with a special coating which is equivalent to 25 millimeter of cover. So, you will get a proper cover for entire area also. So, a punching shear failure slab, a design deficiency has been derived, a column capital has been incorporated, a negative moment reinforcement deficiency has been sufficed by slot and insert carbon fiber laminate, a positive deficiency of moment has been sufficed by insert of steel rebar from the bottom and derived. Now we will go for the last presentation, which is of an industrial plant for repair and strengthening of a tunnel. In one of the fertilizer plant which is located near the seashore, there is a tunnel which is carrying in potash from their bulk storage to the further process. And the tunnel starts at ground level. Below the ground level, 5 meter is the height of the tunnel. So at the starting it is minus 5 meter below the ground level and it slopes towards minus 11 meter. And the sea water, groundwater level is minus 2 meter. The tunnel wall thickness is 1 meter at the bottom and 600 mm at the top. There was lot of leakage, cracks and spalling which was found during routine inspections. They had carried out a large number of type various repair. but the root cause was not determined and not eliminated. So we carry out proper survey, we carry out NDT, the strength was okay, contamination in the concrete were there, leakage was found severe, expansion joint were failed, and the constraint was working condition. Confined space, lot of smell because of potash. You can't work, you can't stay there for a long. It's nearby sea, so during high tide there will be a more leakage, continuous leakage. And plant is in working condition, you cannot stop, conveyor belts are moving. A holistic approach has been decided. Whatever the original wall damage spot has occurred has been reinstated using polymer modified mortar after proper treatment of reinforcement and surface preparation. Injection grouting has been carried out to stop the leakage from the wall, and entire wall of the tunnel has been reinstated, strengthened by providing additional reinforcement with shear anchor and gunneting, 60 mm thick gunneting for M40 grade. After carrying out gunneting, expansion joint has been reprofiled, applied with hypalon strip, but to decrease the pressure of water, a weep holes has been introduced. They has been drilled through the wall for 1.2 meter inside, and all the water pressure in high tides were been released on the wall. So the whole this area becomes dry, this area become dry, and water coming from weep holes only. And then to protect it chemically, to protect it from chemical of potash, a epoxy lining has been carried out. You cannot see the photograph properly because the working condition is very severe. You can't have a good photograph, but this whole entire is epoxy lined. So this way you can have a protection from chemical, you have a way to release the pressure of water, and repair and strengthening has been done. Thank you.